October 14, 1943, 27,000 feet above Schweinfurt, Germany. The morning sun cast long shadows across formations of Boeing B-17 flying fortresses as they pressed deeper into Reich airspace than any daylight bombing mission had dared venture before. For the Luftwaffe fighter pilots racing to intercept, these lumbering four-engine bombers represented easy prey, slow-moving targets whose defensive armament they had learned to exploit over 2 years of combat. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. The German pilots had developed proven tactics against the fortress. Attack from directly ahead where only the nose guns could engage. Dive from high angles where the turrets struggled to track. Coordinate simultaneous strikes from multiple directions to overwhelm the gunners. In the opening months of the American daylight bombing campaign, these methods had yielded devastating results, with loss rates sometimes exceeding 20% of attacking formations. What the Jagdwaffe fighter wings launching that October morning could not have anticipated was that the aircraft they faced bore little resemblance to the B-17s they had first encountered in August 1942. The bomber that had entered combat with 5 defensive guns and blind spots large enough to fly a Messerschmitt through had evolved into something that defied every assumption German tactical doctrine held about heavy bomber vulnerability. The transformation would cost the Luftwaffe its most experienced pilots and fundamentally alter the balance of air power over Europe. The Boeing B-17 flying fortress that began operations over Europe in August 1942 seemed to validate German confidence in their fighter tactics. When the 97th Bombardment Group flew its first mission against the Roissy-Otteville marshalling yards on August 17, 1942, Luftwaffe intelligence officers compiled detailed assessments of the new American bomber. Their conclusions reflected both technical analysis and considerable hubris born from 3 years of combat dominance. The early B-17E model carried defensive armament that German pilots found almost contemptibly inadequate. 5 Browning M250 caliber machine guns provided coverage that left enormous vulnerable zones. A single handheld gun in the nose, manually aimed by the bombardier through a simple frame sight. 2 waist guns, 1 per side, operated by gunners standing in the freezing slipstream without power assistance. A dorsal turret mounting twin 50s behind the cockpit. A ventral turret beneath the fuselage, remotely operated and prone to mechanical failures in the extreme cold of high-altitude flight. The absence of a tail turret represented the most glaring vulnerability. German fighter pilots quickly learned that attacks from 6 o'clock, directly astern, placed them in a zone where no defensive guns could engage. The waist gunners, positioned amidships, possessed insufficient angle to cover the tail approach. Pilots could leisurely position themselves in this blind cone and fire until their ammunition exhausted or the bomber fell from formation. Luftwaffe tactical manuals from late 1942 codified these vulnerabilities into standard attack procedures. Approach from the rear hemisphere where defensive fire remained lightest. Concentrate on stragglers separated from formation mutual support. Target engines and fuel tanks in the wings where fires proved difficult to extinguish. Avoid prolonged exposure to the dorsal turret, which represented the only truly effective defensive position. Early combat statistics supported German confidence. During the first 6 months of American daylight operations, bomber loss rates averaged 7% per mission, with some raids suffering losses exceeding 15%. At these attrition rates, bomber crews had less than a 50% chance of surviving their required 25-mission tour. The mathematics of survival created a grim calculus that threatened the entire strategic bombing campaign. The Regensburg-Schweinfurt missions of August 17, 1943 marked the crisis point. Of 376 bombers dispatched, 60 were shot down with another 17 damaged beyond repair, a combined loss rate approaching 20%. The 8th Air Force could not sustain such casualties. Something had to change, and change radically, or the daylight bombing offensive would collapse under the weight of its own losses. What the Luftwaffe failed to recognize was that American industrial and engineering capabilities were already addressing every vulnerability their tactics exploited. The Boeing engineering teams in Seattle, working in coordination with field modification centers in England, had begun a systematic transformation of the flying fortress that would turn the hunted into the hunter. The critical breakthrough came with the Cheyenne tail gun installation, a modification so significant it redefined bomber defensive doctrine. Engineers designed a complete tail turret housing twin 50 caliber machine guns with 600 rounds per gun, full 360-degree rotation in azimuth and 90 degrees in elevation, electric power traverse allowing rapid target tracking, armor plating protecting the gunner from rear attacks, and heated compartment allowing sustained operations at altitude. The installation required extensive structural modifications. The entire rear fuselage needed reinforcement to handle the turret's weight and recoil forces. Electrical systems required upgrading to power the turret motors. Ammunition feed mechanisms had to route 600 rounds from storage boxes to the guns without jamming. The plexiglass canopy demanded optical quality to allow accurate aiming while withstanding 400 mph slipstream forces. Boeing's Wichita plant began producing B-17F models with factory-installed Cheyenne turrets in May 1943. Simultaneously, modification centers in England began retrofitting earlier B-17ES and early F models with field-installed tail turrets. By September 1943, over 70% of operational fortresses in the 8th Air Force carried tail guns. By November, that figure exceeded 90%. The Chin turret represented the second revolutionary modification, addressing the head-on attack vulnerability that Luftwaffe pilots had exploited with devastating effectiveness. German fighter pilots had learned that attacking directly from 12 o'clock placed them in a zone where only the bombardier's single handheld nose gun could engage. A determined pilot could bore straight in, firing continuously, with minimal risk from defensive fire. The Bendix Chin turret mounted beneath the nose provided the answer. Twin 50 caliber guns with 400 rounds per gun, remote operation by the bombardier from his station, power traverse for rapid tracking, clear field of fire covering the entire forward hemisphere, and integration with existing fire control systems. The B-17G model, entering production in September 1943, featured factory-installed Chin turrets as standard equipment. The effect on German head-on attack tactics proved immediate and devastating. Fighter pilots who had previously pressed attacks to point-blank range now faced converging fire from twin turret-mounted guns that could track far more accurately than handheld weapons. Loss rates among German fighters attempting frontal attacks increased dramatically, forcing tactical revisions that reduced the effectiveness of what had been their most successful approach. But the transformation extended far beyond adding turrets. Boeing engineers systematically upgraded every aspect of the defensive armament system, creating an integrated weapons platform that multiplied the effectiveness of each individual gun position. The improvements encompassed fire control, ammunition systems, crew protection, and tactical coordination. The computing gun sight represented a technological leap that transformed gunnery accuracy. Earlier models used simple ring and bead sights requiring gunners to estimate lead angles mentally. The new K-13 and K-14 computing sights incorporated gyroscopic mechanisms that automatically calculated the proper lead angle based on target range, angular velocity, and aircraft speed. The gunner simply placed the illuminated reticle on the target and the sight compensated for relative motion. Field testing demonstrated dramatic improvement in hit probability. A 1944 gunnery study conducted by the 8th Air Force revealed that gunners using computing sights achieved twice the hit rate of those using iron sights at ranges beyond 400 yards. At extended ranges of 600 to 800 yards, the advantage increased to 3 times the hit probability. This meant defensive fire became effective at ranges where attacking fighters previously operated with impunity. Ammunition improvements increased both the quantity carried and the destructive effect delivered. Early B-17 models carried approximately 4,000 rounds total for all defensive positions. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The fully modified B-17G carried over 11,000 rounds distributed across 13 gun positions. This represented nearly 3 times the total ammunition load, allowing sustained defensive fire throughout prolonged fighter attacks. The ammunition itself evolved to increase lethality. Standard loadings mixed armor-piercing incendiary, tracer, and ball rounds in specific ratios optimized for different tactical situations. The M8 armor-piercing incendiary round could penetrate the armor-protecting German fighter cockpits and engines at ranges exceeding 500 yards. When these rounds struck, they ignited incendiary compound that started fires in fuel systems and hydraulic lines. Tracer rounds served dual purposes, allowing gunners to observe bullet trajectory for aim correction while simultaneously creating psychological effects on attacking pilots. German after-action reports frequently mention the unnerving effect of tracers converging from multiple turrets, creating what pilots described as a cage of fire that seemed impossible to penetrate. The final evolved armament configuration of the B-17G represented a quantum leap from the inadequate defensive suite of the early E model. 13 Browning M250 caliber machine guns provided overlapping fields of fire covering every approach angle. Twin guns in the chin turret covering the entire forward hemisphere. Twin guns in the dorsal turret providing top coverage. Twin guns in the ball turret protecting the lower fuselage. Twin guns in the tail turret eliminating the rear blind spot. Single guns at each waist position for beam defense. Twin guns in the radio room dorsal position. A single cheek gun on each side of the nose for oblique forward defense. This armament represented the most heavily defended bomber in operational service anywhere in the world. The Soviet P-8 carried fewer guns with less effective coordination. The British Lancaster relied primarily on evasive maneuvers rather than defensive firepower. The Japanese G4M possessed almost no effective defensive armament. Only the B-29 Superfortress, not yet operational, would exceed the B-17G's defensive capabilities. The total firepower available staggered comprehension. 13 guns each firing at 750 to 850 rounds per minute delivered a combined rate of fire exceeding 10,000 rounds per minute. In practical terms, a fully armed B-17G could put more than 160 half-inch diameter bullets into the air every second. The weight of fire in a 3-second burst exceeded 40 pounds of metal and explosive, enough to destroy any fighter aircraft ever built. But raw firepower meant little without the ability to bring guns to bear effectively. The true revolution lay in fire control coordination and crew training that transformed 13 individual weapons into an integrated defensive system. The procedures developed through painful combat experience created defensive tactics that multiplied the effectiveness of the armament. The combat box formation represented the tactical foundation of B-17 defensive doctrine. Rather than flying in loose VICs or echelons, bombers flew in tight three-dimensional boxes that maximized overlapping fields of fire. A standard 18-aircraft combat box positioned bombers so that any attacking fighter faced fire from at least 4 different aircraft regardless of attack angle. The lead squadron flew at the formation center at the assigned altitude. The high squadron positioned itself 500 feet above and slightly behind, offset to provide clear firing lanes. The low squadron flew 500 feet below and offset to the opposite side. Within each squadron, flights of 3 aircraft flew in precise positions that allowed mutual support while preventing masking of defensive fire. The geometry created killing zones where converging fire from multiple bombers reached lethal density. Mathematical analysis conducted after the war demonstrated that a fighter attacking a properly flown combat box faced defensive fire from 40 to 50 guns simultaneously at the point of maximum exposure. The probability of taking hits approached certainty if the pilot maintained his attack run for more than 3 seconds. German fighter pilots learned to respect these killing zones through bitter experience. Veteran Jagdwaffe pilot Hans Philipp, who commanded JG-1 until his death in October 1943, described the evolution of defensive firepower in his combat journal. His account provides rare insight into how experienced German pilots adapted their tactics in response to improving American defensive capabilities. Philipp wrote in August 1943 that early attacks against B-17 formations allowed approach to within 200 meters before defensive fire became dangerous. By September, that distance had increased to 400 meters as tail turrets became universal and gunner training improved. By October, Philip noted that any approach within 600 meters resulted in immediate heavy defensive fire from multiple aircraft, forcing pilots to break off attacks earlier and accept lower hit probabilities. The gunner training program developed by the USAF transformed raw recruits into skilled aerial gunners through intensive instruction that far exceeded anything the Luftwaffe provided its defensive gunners. American gunners underwent 6 weeks of basic training followed by 6 weeks of specialist gunnery school. The curriculum emphasized aircraft recognition, ballistics, lead computation, turret operation, malfunction clearing, and coordination with other crew members. Advanced training used moving targets towed behind aircraft, allowing gunners to practice tracking and firing at realistic closing speeds. Skeet shooting developed the reflexes needed for deflection shooting. Classroom instruction covered fighter tactics, enabling gunners to anticipate attack patterns and position their turrets for optimal engagement. By the time gunners reached operational squadrons, they had fired thousands of practice rounds and could identify aircraft types at distances exceeding 1,000 yards. The contrast with Luftwaffe training proved stark. German bomber gunners typically received 2 weeks of basic instruction with minimal live fire practice. Combat doctrine emphasized fighter escort rather than defensive armament, creating a self-fulfilling prophecy where poorly trained gunners proved ineffective, reinforcing the doctrine that defensive guns provided little value. The Luftwaffe never developed the systematic gunnery training that made American bombers such formidable opponents. Communication and coordination between gun positions multiplied defensive effectiveness beyond what individual gunners could achieve in isolation. The B-17's intercom system allowed continuous voice communication between all crew positions. Standard procedures required gunners to call out fighter positions using clock code and altitude references, enabling other gunners to track threats not yet visible from their positions. The tail gunner served as the formation's early warning system, with the clearest view of approaching fighters from the rear hemisphere. His calls of incoming threats gave dorsal and waist gunners seconds of additional reaction time to position their weapons. Similarly, the chin turret operator could alert cheek gunners and top turret to fighters approaching from ahead, allowing coordinated fire that increased hit probability. This coordination created defensive synergies impossible for lone gunners to achieve. When multiple gunners engaged the same target, their converging fire created a cone of bullets that dramatically increased hit probability. Even if individual gunners achieved only moderate accuracy, the combined effect of 4 or 5 guns firing at the same target made hits nearly inevitable if the fighter maintained his attack run. The psychological effect on attacking German pilots proved as significant as the physical damage inflicted. Fighter pilots accustomed to operating with impunity now faced situations where any attack run resulted in their aircraft being struck by defensive fire. Even if the hits caused no critical damage, the constant pinging of .50 caliber rounds on airframe and the spider web cracking of canopy hits created enormous stress. Luftwaffe pilot Friedrich Lang, who survived the war with 173 victories primarily on the Eastern Front but flew against B-17s during temporary assignment to the West in late 1943, described the psychological impact in post-war interviews. Lang stated that attacking Russian bombers felt almost like target practice, as their defensive armament posed minimal threat. Attacking American boxes felt like flying into a storm of steel where survival depended more on luck than skill. Lang's account detailed the mental calculus every pilot performed before committing to an attack. Press the attack to effective gun range and almost certainly take hits, possibly fatal. Break off early and waste ammunition with little chance of bomber destruction. The improved defensive firepower forced German pilots into impossible choices where both options carried severe penalties. The second Schweinfurt mission of October 14, 1943 provided the first large-scale demonstration of the fully evolved B-17 defensive system. Of 291 bombers dispatched, 229 carried the new tail turrets and improved armament suites. The results differed dramatically from previous deep penetration missions that had suffered catastrophic losses. The attacking Luftwaffe formations threw everything available at the bomber stream. JG-1, JG-11, JG-26, and JG-3 launched over 300 fighter sorties, the largest German fighter concentration of 1943. They employed their full repertoire of tactics: head-on attacks, coordinated strikes from multiple directions, extended pursuit of damaged stragglers. The battle raged for over an hour as bombers fought their way to the target and back. The American losses proved severe, with 60 bombers failing to return. But the exchange ratio had shifted dramatically from previous missions. Bomber gunners claimed 186 German fighters destroyed, with post-war analysis confirming at least 38 fighters lost and another 28 damaged beyond economical repair. More significantly, the Luftwaffe lost 47 pilots killed or missing, including 5 irreplaceable formation leaders with years of combat experience. The mathematics had changed. Where previously the Luftwaffe could inflict 5 bomber losses for every fighter destroyed, the ratio now approached parity or worse. The B-17s were fighting back effectively enough that attacking them became prohibitively expensive for the German fighter forces. Veteran pilots who survived the mission reported that defensive fire had become so intense that standard attack tactics no longer worked. The testimony of these survivors reaching Luftwaffe high command triggered a crisis in German air defense strategy. If fighters could not destroy bomber formations without suffering unsustainable losses, what options remained? The answers developed over subsequent months showed how desperately the Luftwaffe sought solutions to the B-17 defensive firepower problem. One approach involved standoff attacks using heavy weapons that allowed fighters to engage beyond effective defensive gun range. The Werfer Granit 21 rocket, a 21 cm unguided projectile carried under fighter wings, could be launched from 1,200 meters distance. The massive warhead could destroy a bomber with a near-miss through blast effect alone. From October 1943 through early 1944, significant numbers of German fighters carried these weapons. Combat results proved disappointing. The rocket's inaccuracy meant hit probability remained below 5% even against formation-sized targets. The weapon's weight and drag reduced fighter performance significantly, making rocket-equipped aircraft vulnerable to escort fighters. Worst of all, launching required fighters to hold steady course for several seconds, creating perfect targets for bomber defensive gunners using computing sights. Another approach involved heavily armored and armed destroyer aircraft, Zerstörer designed specifically for bomber combat. The Messerschmitt Bf-110G carried additional armor plating protecting the pilot and engines, plus heavy forward-firing armament including 37mm or 50mm cannon. The theory held that these aircraft could survive defensive fire long enough to close to point-blank range and deliver killing blows with heavy cannon. Reality again differed from theory. The added armor made these aircraft slow and unmaneuverable, easy prey for American escort fighters that began appearing in strength in early 1944. When forced to engage without escort fighter top cover, the heavy Zerstörer suffered catastrophic losses. Their brief operational career demonstrated that armor alone could not overcome the volume of fire multiple B-17 gun positions could concentrate on a single target. The Sturmbach units represented the most extreme response to B-17 defensive firepower. These specially equipped Focke-Wulf 190s carried extraordinary armor protection: 30mm face plate on the canopy, 50mm armored glass in the windscreen, 5mm cockpit armor on all sides, 6mm additional armor protecting critical engine components, and armor plating beneath the fuselage protecting fuel tanks and hydraulic systems. Total additional armor weight exceeded 1,000 pounds. This mobile fortress concept assumed that sufficient armor would allow pilots to press attacks to point-blank range regardless of defensive fire. Pilots would bore straight in, ignoring the bullets that would inevitably strike their aircraft, and destroy bombers with concentrated cannon fire at ranges under 100 meters. The doctrine explicitly accepted that these aircraft would take severe damage on every mission. Operational results proved the concept fundamentally flawed. While the armor protected pilots from many hits, the sheer volume of fire from B-17 combat boxes overwhelmed any realistic level of protection. Multiple guns firing simultaneously achieved hits on unarmored components, control surfaces, landing gear, cooling systems, and ammunition feeds. Even if the pilot survived, his aircraft often suffered damage that forced emergency landing or abandonment. The tactical employment of Sturmbach units revealed their desperation. Formations of these heavily armed and armored fighters would form up and execute mass frontal attacks, attempting to overwhelm defensive fire through sheer numbers. The attacks required nerves of steel as pilots flew directly into converging fire from dozens of guns. Loss rates among Sturmbach units exceeded 40% per mission, a casualty rate no air force could sustain. The statistical record of late 1943 and early 1944 demonstrates how B-17 defensive improvements shifted the balance. Monthly 8th Air Force bomber losses declined from 9.2% in October 1943 to 6.1% in December 1943 to 3.8% in February 1944. Simultaneously, the confirmed kill ratio of German fighters destroyed versus bombers lost shifted from 0.4:1 in August 1943 to 0.8:1 in December 1943 to 1.1:1 by March 1944. These statistics represented the death knell of German air defense strategy. An air force cannot sustain a campaign where it loses more fighters than it destroys bombers, especially when fighter-pilot training requires 6 months while bomber crews can be replaced in weeks. The mathematics of attrition had reversed, and the Luftwaffe found itself in an unwinnable war of numbers. Individual combat reports from B-17 missions illustrate how the enhanced defensive armament transformed bomber survivability. The mission to Brunswick on January 11, 1944 provides a detailed example preserved in 8th Air Force records. The 306th Bombardment Group, flying in the low position of the 40th Combat Wing, faced sustained attacks from an estimated 40 German fighters over a 20-minute period. The group's formation of 18 B-17GS maintained integrity throughout the engagement, with no aircraft lost to fighter attack. Gunners fired approximately 18,000 rounds, achieving hits on 23 different fighters with 8 confirmed destroyed through multiple witnesses and gun camera footage. The tail gunner of Lieutenant Morrison's aircraft, Staff Sergeant Robert Harmon, destroyed 3 Focke-Wulf 190s in individual engagements, demonstrating how well-trained gunners using improved sights and turrets could achieve remarkable results. The debriefing reports reveal the tactical patterns that made the defensive system so effective. Fighters attempting frontal attacks faced immediate fire from Chin turrets at ranges exceeding 800 yards. As they closed, cheek guns and top turret added their fire, creating converging streams that damaged or destroyed attackers before they reached effective firing range for their own weapons. Fighters attempting stern attacks found themselves engaged by tail turrets that could track smoothly through the entire rear hemisphere. Most tellingly, the reports note that German fighters broke off attacks earlier than in previous months, unwilling to press through the defensive fire to point-blank range. The psychological effect of improved defensive firepower had shifted German tactics from aggressive pressing attacks to more cautious standoff approaches that reduced their effectiveness proportionally. The contribution of individual gunners' skill to defensive effectiveness cannot be overstated. The most successful aerial gunners achieved remarkable records that rivaled fighter pilot aces in their impressiveness. Staff Sergeant Michael Aruth of the 379th Bombardment Group achieved 14 confirmed aerial victories, making him the highest-scoring aerial gunner of the war. His achievement required not just marksmanship but tactical awareness, quick reaction, and the ability to function effectively under extreme stress. Technical Sergeant Arthur Benko of the 490th Bombardment Group demonstrated how effective gunnery could protect an entire formation. Flying as tail gunner, Benko claimed 9 confirmed victories and 15 probables over his combat tour. His aircraft never suffered serious damage from fighter attack, as his accurate fire forced attacking pilots to break off before reaching optimal firing positions. His squadron commander credited Benko's gunnery with saving multiple aircraft that would otherwise have fallen to fighter attack. The training and experience that created such skilled gunners took months to develop but proved invaluable in combat. Veteran gunners learned to identify fighter types by silhouette at extreme ranges, anticipate attack patterns based on aircraft type and tactical situation, compensate for relative motion without conscious calculation, and maintain fire discipline to avoid wasting ammunition on out-of-range targets. These skills transformed adequate gunners into true aerial warriors. The enhanced defensive firepower created a virtuous cycle that further improved bomber survivability. As German fighters suffered increasing losses, the quality of their pilot replacements declined. Veteran pilots who understood effective attack tactics were killed or injured faster than they could be replaced. Replacement pilots received increasingly abbreviated training as fuel shortages reduced flight time. These inexperienced pilots proved far less effective against the B-17's defensive system. Simultaneously, American gunner experience levels increased as loss rates declined. Crews surviving multiple missions accumulated tactical knowledge that made them progressively more dangerous opponents. The percentage of 8th Air Force gunners with 10 or more combat missions increased from 20% in September 1943 to over 60% by March 1944. This experience advantage multiplied the effectiveness of the already superior defensive armament. The arrival of long-range fighter escorts in early 1944 completed the transformation of the bomber defensive equation. P-51 Mustangs with sufficient range to escort bombers to any target in Germany arrived in force beginning in December 1943. Their presence forced German fighters to engage escorts before reaching bombers or accept fighter attack while attempting bomber interception. Either option degraded the effectiveness of attacks against the bomber formations. The combination of improved defensive armament and fighter escort created an impossible situation for the Luftwaffe. Fighters that evaded escort encountered bomber formations with devastating defensive firepower. Fighters that pressed attacks despite defensive fire exposed themselves to escort fighters diving to the bomber's defense. The tactical options narrowed to choosing between different forms of defeat. The Big Week operations of February 20th to 25th, 1944 demonstrated the culmination of these developments. Over 6 days, the 8th and 15th Air Forces dispatched over 3,800 heavy bomber sorties against German aircraft production facilities. The Luftwaffe threw everything available into defense, flying over 2,000 fighter sorties. The resulting air battles represented the largest sustained aerial combat in history. American losses totaled 226 heavy bombers, approximately 6% of sorties dispatched. German losses exceeded 355 fighters destroyed with another 200 damaged, over 30% of fighters committed. More critically, the Luftwaffe lost 100 fighter pilots killed, wounded, or captured, including 17 formation leaders and senior pilots whose experience could never be replaced. The exchange ratio had become decisively favorable to American forces. The spring of 1944 witnessed the complete reversal of the air superiority equation over Europe. Where German fighters had once hunted American bombers with relative impunity, they now faced formations whose defensive firepower extracted such devastating casualties that attack itself became a form of suicide mission. The B-17G represented the culmination of this evolution, a weapons system so thoroughly developed that it invalidated 2 decades of German tactical doctrine regarding bomber vulnerability. The operational statistics from March through May 1944 tell a story of transformation so complete that it reshaped strategic thinking about aerial warfare. 8th Air Force bomber loss rates stabilized at 3 to 4% per mission, a figure that allowed sustainable operations and crew rotation. More significantly, the ratio of German fighters destroyed to bombers lost reached 1.3 to 1 by April, meaning the Luftwaffe lost more fighters than it destroyed bombers in defensive operations. These numbers represented mathematical impossibility for German air defense. Fighter production, even at peak efficiency, could not replace losses at these rates while simultaneously covering other theaters and maintaining training establishments. The Luftwaffe faced the prospect of exhausting its fighter forces through defensive operations meant to protect German industry. The defensive had become offensive through the simple mechanism of making defense prohibitively expensive. Individual mission reports from this period reveal how thoroughly B-17 defensive firepower dominated tactical engagements. The Berlin mission of March 6, 1944 exemplifies the pattern. The 1st Bomb Division dispatched 214 B-17s against targets in the German capital, the deepest penetration yet attempted in daylight. Luftwaffe controllers scrambled every available fighter, assembling an estimated 250 aircraft for the interception. The resulting air battle raged across 150 miles of German airspace as fighters pressed repeated attacks against the bomber stream. The 1st Division lost 22 bombers to all causes, a loss rate just over 10% that seemed substantial until compared to confirmed German fighter losses. Post-mission analysis credited bomber gunners with 97 fighters destroyed, later reduced to 68 confirmed through correlation with German loss records. Even accepting the conservative figure, the exchange ratio exceeded 3 German fighters lost for every bomber destroyed. The debriefing reports from surviving crews describe a tactical environment transformed from earlier combat. German fighters approached cautiously, often breaking off attacks when defensive fire began without pressing to effective gun range. Formation leaders reported that maintaining tight defensive boxes proved sufficient deterrent against most attacks, with fighters preferring to search for stragglers or damaged aircraft rather than penetrate concentrated defensive fire. The psychological transformation among bomber crews proved as significant as tactical changes. Where crews in 1943 felt helpless against fighter attacks, dependent on luck and formation position for survival, crews in 1944 possessed confidence in their defensive capabilities. This confidence translated into better fire discipline, calmer reactions under attack, and more effective coordination between gun positions. The mental state of being hunter rather than hunted improved performance across every aspect of defensive operations. The technical refinements continued throughout 1944, with field modifications and factory improvements creating progressively more capable defensive systems. The lightweight tail turret introduced in April 1944 reduced weight by 150 pounds while maintaining full firepower, improving aircraft performance without sacrificing defensive capability. New ammunition feed systems reduced jamming rates from approximately 8% to under 2%, meaning guns remained operational throughout extended engagements. The K-14 computing gun sight entered widespread service in May 1944, representing another quantum leap in fire control effectiveness. This gyroscopic sight incorporated lead computing mechanisms far more sophisticated than earlier models, automatically calculating deflection angles for targets maneuvering in 3 dimensions. Gunners simply placed the illuminated pipper on the target and the sight adjusted aim point for all relative motion factors. Field testing of the K-14 demonstrated hit probabilities double those achieved with earlier K-13 models. At 500 yards range against a target crossing at 30 degrees deflection, the K-14 sight increased hit probability from 12% to 24% for average gunners. For skilled gunners who understood the sight's capabilities, hit rates exceeded 35%, making defensive fire lethal at ranges where fighters had previously operated safely. The integration of radar warning systems in late 1944 provided another defensive advantage, though one less visible than guns and turrets. APS-13 tail warning radar gave crews detection of approaching fighters at ranges exceeding 1,500 yards, providing critical seconds of additional reaction time. The system proved especially valuable during night operations or in cloud conditions where visual detection distances decreased dramatically. The combination of these technological improvements created a defensive system that exceeded the sum of its components. Computing sights multiplied the effectiveness of existing guns. Radar warning expanded the envelope within which computing sights could engage targets. Improved ammunition feed systems ensured weapons remained operational throughout the engagement window radar and sights created. Each element reinforced the others in a cascade of capability improvements. The German response to these defensive developments revealed the bankruptcy of their tactical options. Every approach attempted proved insufficient to overcome the B-17's evolved defensive firepower without suffering unsustainable casualties. The desperation measures implemented grew progressively more extreme as conventional tactics failed, yet none provided the breakthrough German commanders desperately sought. The Ramjager ramming units represented perhaps the most desperate expedient. These volunteer pilots, would deliberately ram bombers with their fighters after exhausting ammunition, sacrificing their aircraft and accepting probable death to guarantee bomber destruction. The tactic assumed that even the B-17's formidable defensive firepower could not prevent a determined pilot from closing to ramming distance if he ignored all personal safety. The first organized Ramjager mission launched on April 7, 1944 against formations attacking German synthetic fuel plants. Approximately 120 fighters from Sonderkommando Elba flew the mission, with pilots explicitly briefed to ram bombers if conventional attack failed. The results demonstrated both the courage of German pilots and the futility of the tactic. Of 120 fighters committed, only 8 successfully rammed bombers. The remainder were shot down by defensive fire, destroyed by escort fighters, or crashed due to battle damage before reaching ramming distance. The exchange ratio proved catastrophic. 8 bombers destroyed through ramming, 23 additional bombers shot down through conventional attack, totaling 31 bomber losses. German fighter losses exceeded 80 aircraft with 67 pilots killed, wounded, or missing. Even a tactic predicated on accepting pilot death to guarantee bomber kills achieved less than 1 bomber destroyed per pilot lost. The mathematics made Ramjager operations impossibly expensive. The attempt to employ unconventional weapons against bomber formations produced similarly disappointing results. The SG-500 Jagdwaffe, an upward-firing mortar installation in fighter aircraft, would automatically trigger when the fighter passed beneath a bomber, firing shells through the vulnerable belly. The system required no pilot input beyond positioning the aircraft, eliminating the marksmanship challenge that made conventional attacks difficult. Combat trials revealed fatal flaws. The automatic triggering mechanism often fired prematurely or failed to fire at optimal range. The mortar shells lacked sufficient velocity to guarantee hits against maneuvering bombers. Most critically, the installation required fighters to approach directly beneath bombers, flying through the concentrated fire of ball turrets and waist guns. Loss rates among aircraft carrying the system exceeded 50% per mission, forcing abandonment of the concept after less than 2 months of operations. German fighter pilot memoirs from this period convey the psychological impact of facing improved B-17 defensive firepower. Heinz Nock, who survived the war with 33 confirmed victories, described attacking American bomber formations as the most terrifying experience of his combat career. His autobiography quotes directly from his wartime diary, entries that capture the mental state of pilots facing defensive fire far exceeding anything in their training or experience. Noak's diary entry from May 1944 describes an attack against a formation of B-17s returning from a raid on synthetic fuel plants. His approach from high forward quarter, a tactic that had succeeded in 1943, now resulted in immediate engagement from chin turrets, cheek guns, and top turrets simultaneously. The convergence of tracers created what he described as a glowing net impossible to penetrate. His aircraft took 3 hits in the engine cowling before he broke off the attack, forcing emergency landing at a forward airfield. The entry concludes with Noak's assessment that attacking American bombers had become nearly suicidal for single-engine fighter pilots. He noted that even successful attacks resulting in bomber destruction typically left the attacking fighter damaged, often severely. The risk-reward calculation had shifted to where destroying a bomber required accepting probable loss of the attacking fighter. This equation made defensive operations strategically untenable regardless of tactical outcomes. Johannes Steinhoff, another Luftwaffe ace who survived the war and later commanded the post-war German Air Force, provided similar testimony in his memoir The Last Chance. Steinhoff commanded JG-77 during 1944, leading combat operations against American bomber formations throughout that summer. His tactical analyses reveal how completely the defensive firepower problem dominated German fighter operations. Steinhoff wrote that by mid-1944, standard fighter tactics against bombers had evolved into elaborate schemes to minimize exposure to defensive fire while maximizing chances of bomber destruction. These tactics involve coordinated attacks from multiple directions to divide defensive fire, concentration of entire formations against single bomber groups to overwhelm defenses through numbers, and extended stern chases where fighters would fire from maximum range hoping for lucky hits rather than pressing close-range attacks. The memoir notes that none of these adaptations proved satisfactory. Coordinated attacks required timing and discipline difficult to achieve with inexperienced pilots. Concentration tactics left other bomber formations unmolested and required accepting losses among the concentrated fighters. Extended stern chases consumed fuel while achieving minimal results due to range limitations of fighter weapons. Every option involved unacceptable compromises. Most tellingly, Steinhoff's memoir describes the progressive decline in pilot morale as the defensive firepower problem proved insoluble. Experienced pilots who understood effective attack tactics were killed or injured faster than they could transmit knowledge to replacements. Replacement pilots arrived with insufficient training, lasted only a handful of missions before becoming casualties, and never developed the skill needed to attack effectively. The cycle created a death spiral where fighter effectiveness declined even as production increased. The quantitative analysis of ammunition expenditure patterns reveals how B-17 defensive firepower shaped tactical behavior. Statistical studies conducted by the 8th Air Force Operational Research Section tracked ammunition consumption per bomber per mission throughout 1943 and 1944. The data shows dramatic evolution in engagement patterns as defensive capabilities improved. In August 1943, average ammunition expenditure per bomber per mission approximated 600 rounds across all gun positions. This relatively modest consumption reflected limited engagement opportunities as German fighters attacked with impunity and defensive fire proved largely ineffective. By December 1943, average expenditure had increased to 950 rounds per bomber per mission, indicating longer engagements and more frequent fighter contacts. March 1944 saw expenditure reach 1,250 rounds per bomber per mission as computing sites and improved turrets allowed engagement at longer ranges. June 1944 expenditure exceeded 1,400 rounds, reflecting the reality that improved defensive effectiveness encouraged gunners to engage any fighter within range rather than reserving fire for point-blank encounters. The increasing ammunition consumption demonstrated growing confidence in defensive firepower effectiveness. The correlation between ammunition expenditure and fighter loss rates proved statistically significant. Missions where average ammunition consumption exceeded 1,200 rounds per bomber showed German fighter loss rates 40% higher than missions with consumption below 800 rounds. The data suggested that aggressive defensive fire, enabled by improved sights and unlimited ammunition, forced German fighters to break off attacks earlier, reducing their effectiveness while increasing their exposure to defensive fire. The economic efficiency of the B-17 defensive system demonstrated remarkable cost-effectiveness when analyzed through industrial production metrics. Each B-17G cost approximately $238,000 to manufacture in 1944 dollars, representing about 400,000 man-hours of labor across all production stages. The defensive armament suite, including all 13 guns, turrets, sights, and ammunition systems, accounted for roughly $31,000 of this total, approximately 13% of aircraft cost. This investment provided defensive capability sufficient to deter or destroy attacking fighters valued at $100,000 to $150,000 each for single engine types. The mathematical proposition proved compelling. If defensive armament prevented the loss of even a single bomber over the aircraft's operational life while destroying or deterring multiple fighters, the investment returned multiples of its cost through preserved bombers and destroyed enemy assets. The operational statistics bore out this analysis. The average B-17G completed 76 combat sorties before loss to all causes, including operational accidents, flak, and fighter attack. Over this operational life, the average aircraft's gunners claimed 3.2 enemy aircraft destroyed with 1.8 confirmed through multiple sources. Even accepting only confirmed kills, each bomber destroyed nearly 2 fighters valued collectively greater than the bomber's manufacturing cost, while completing dozens of bombing missions delivering strategic effect. The preservation value proved even more significant. Each bomber loss meant the death or capture of 10 highly trained crew members, representing collective training investment exceeding $250,000. The defensive armament that prevented bomber loss therefore saved not just aircraft replacement cost but also crew training investment and the irreplaceable experience of veteran crews. The cascading economic benefits of effective defensive firepower far exceeded the direct cost of the defensive systems themselves. The strategic implications of B-17 defensive effectiveness extended beyond immediate tactical outcomes. The shift in exchange ratios fundamentally altered the calculus of daylight strategic bombing, making it sustainable where it had previously threatened to collapse under unsupportable losses. This sustainability allowed the progressive destruction of German war production through sustained bombing campaigns that earlier loss rates would have made impossible. The Combined Bomber Offensive Directive issued in June 1943 had established ambitious targets for destruction of German industrial capacity. The plan assumed acceptable loss rates around 4% per mission, allowing bomber forces to sustain operations while progressively destroying target systems. Through late 1943, actual loss rates averaging 7 to 9% made these objectives unattainable. The mathematics indicated bomber forces would exhaust themselves before achieving significant strategic effect. The defensive improvements that reduced loss rates to sustainable levels beginning in early 1944 transformed this equation. Missions could proceed against any target in Germany with reasonable confidence that losses would remain within acceptable parameters. This capability allowed systematic campaigns against critical industries, particularly synthetic fuel production, that proved devastating to German military effectiveness. The oil campaign launched in May 1944 demonstrated how sustainable loss rates enabled strategic effect. Over 6 months, repeated raids against synthetic fuel plants reduced German production from 316,000 tons monthly in March 1944 to 17,000 tons by September 1944, a 95% reduction. These missions faced heavy fighter opposition but achieved objectives because B-17 defensive firepower kept losses within sustainable bounds. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.